the sum s is equal to the sum from I equals 1 to 14th of I over 2 to the I. And we want to see what this is equal to. So let's write out a couple of the terms. It's 1 over 2 plus 2 over 2 squared, 3 over 2 cubed, and then it's going to be plus 13 over 2 to the 13th plus 14 over 2 to the 14th. Okay. Now, in order to solve this, what I'm going to do is subtract. I'm going to multiply this by 1/2 and then subtract. So if I multiply this top row by a half, we have 1/2 s is equal to, and then just multiply each one by a half. So that's going to be 1 over 2 squared plus 2 over 2 cubed plus 3 over 2 to the 4th plus, I'm going to skip the last one here, and I'm going to go over here. That's going to be, 13, we'll do this one. 13 over to the 14th, and then 14 over to the 15th. So when I subtract these, s minus a half s is 1/2 s. And then what I'm going to do is I'm going to pair them up like this. So these two are just going to drop as they are. So the 1/2 comes down, and then 2 over 2 squared minus 1 over 2 squared is 1 over 2 squared. 3 over 2 cubed minus 2 over 2 cubed is 1 over 2 cubed. All the way up to 14 over 2 to the 14th minus 13 over 2 to the 14th is 1 over 2 to the 14th. And then this 14th to the 15th, we're subtracting, so that comes out as a negative. And so now this is a geometric sum, or series, at least this part right here. So the formula is going to be the first term minus the omitted term, which is the term that comes after the last one. So just multiply that by 1/2, divided by 1 minus the ratio. And here I can factor out a 1/2. We have 1/2, and then 1 minus 1 over 2 to the 14th over a half minus 14 over 2 to the 15th. I can cancel the halves and have 1/2 s equals 1 minus 1 over 2 to the 14th minus 14 over 2 to the 15th. Notice that these two denominators are not the same. So I'm going to find a common denominator, which is 2 to the 15th. So I'm just going to multiply this one by 2 over 2. And now I can subtract these. We have 1/2 s equals 1 minus 16 over 2 to the 15th. And then 16 is just 2 to the 4th. So if I subtract the 4 and the 15, I get 11. And notice that I want to solve for s. I want to solve for the original one here. But I have 1/2 s. So in order to get s, I need to multiply both sides by 2. So the 2's cancel. I'm left with s equals 2 minus 1 over 2 to the 10th. And 2 to the 10th is just 1048, or 1024, I mean. And if I multiply this one by 1024, which is the common denominator, we have s is equal to 2048 over 1024 minus 1 over 1024. Subtracting these, we get s is equal to 2047 over 1024. And that's going to be the sum.